let's solve the problem. Now, the first thing we need to do is to write down the problem, which is maximize over TA and TB greater or equal than 0, 10 logarithm of TA plus 1 plus 20 logarithm of TB plus 1, subject to the constraint that TA plus TB has to be equal to the 9 hours that are available. Using the same tricks as before, we can rewrite this problem as maximize over TA greater or equal than 0 and TA less or equal than 9, 10 logarithm of TA plus 1 plus 20 logarithm of 10 minus TB. It should be obvious that all that we have done is to use the equality constraint to substitute for the value of TB. This is a typo here as a function of A. So this is TB plus 1 as a function of TA. Now, to solve the problem, we need to see whether it falls in the interior or corner case as a first step. So step 1, is there an interior solution? How do we approach this? We have to look at the graph for the first order conditions as a function of TA, which is the way we have simplified the problem. Well, we know that TA can go between 0 and 9. We also know that when TA is 0, the marginal value, remember in our interpretation that we have been using, this is the benefit, the marginal value is going to be 10 of the benefit, and when TA is 9, this is its value is going to be given by 10. Well, let me write it here not to confuse you. It's going to be 10 divided by 10. So we have a marginal value function that goes like this. This is the benefit of TA prime. Now in another color, I'm going to plot the cost, and remember we can think of minus 20 logarithm of 10 minus 10a as the cost function, as a function of TA, and it's easy to see that that function crosses here at a value of 20 and crosses here at a value of 20 divided by 10. So it does something like this. Now, given that 20 divided by 10 is much lower than 10 and 20 is much greater than 1, we know that there is going to be an interior solution. So X star is interior. Now, what's the second step? Now that we know that the solution is interior, we can apply the formulas that we have. So we know that TA star and TB star are going to solve the following two equations. One is, remember, in the shape of the problem, just to so you follow best, this is going to be the equivalent of U of TA, and this is going to be equivalent to B of TB. So what we know is we're going to want to have is U prima divided by B prima equal to the prices. This is the equality constraint, the linear equality constraint, but the prices here are equal to 1. So this is going to be divided by 1 divided by 1. These are the P's and the Q's that were here in the general problem before. And the second equation is TA plus TB is equal to 1. If you take the derivatives, you find out that this equation, that the U prima, B prima, is going to be given by 10 divided by TA plus 1, and B prima is 20 divided by TB plus 1 at the optimum. And the budget constraint is going to have TB, I apologize, that number, so there's a typo there, should have been a 9, and the TB is going to be equal to 9 minus TA, again a star, and if you do some algebra, you find that TA is equal to 8/3 and TB is equal to 19/3 at the optimum. Now, as before, let's use our economic intuition to check the validity of the solution, or to be more precise, its plausibility. We see that the value that you place on the benefit on spending time on B is greater than spending time on A by a factor of 2 in this coefficient, and yet you find that the amount of time that you spend on B is greater than the amount of time that you spend on A, which makes sense. What is interesting is that it is more than twice in difference or in ratios, but intuitively it makes sense. Let me highlight one more thing about this example, which is, in principle, it looks very different from the consumer problem, and yet it's very easy to see that it's exactly the same structure with a function u, a function b of two goods, and the total allocation of time having to be less or equal than something looks just like a budget constraint with prices equal to 1. So it's just a similar version of the problem that we have seen before, and I hope that gives you an intuition for why these problems are so canonical, because they show up all over the place, even in situations that look very different from a standard consumer problem in economics.